So I just want to welcome everybody. Thank you to all, and thanks to altE for hosting. S-5 has worked with altE and attended conferences for almost 10 years now, and I think this is your 11th. So congratulations on that. Just a quick introduction. My name is David Stoller, Director of Sales. My email is up there, and I've been with S-5 for 10 years. Also have Mark Geis with us, who is Director of Solar Business. And he's been with S-5 for about 3 years. You want to say a quick hello?
Yeah, hi. So I'm Mark Geis, Director of Solar Business at S-5. I've been at S-5 probably like 2.5-ish years. I've been in the solar space for more than a dozen years now. And most of that has been with racking. So that's been kind of my bailiwick is mounting systems. So thanks for attending.
All right, well, let's start this. So welcome to railless solar on metal roofs. This is going to be railless, so what we call direct attach, and we're going to talk about some wire management and some best practices and some things like that. A little bit about S-5. Understand that we're talking about direct attach today, but S-5 is a metal roof attachment company. We've been around for almost 30 years, so you can attach anything with our products. So that includes, if you were using rails, you could attach the rails directly to our products and all the ancillaries for all your solar needs: electronics, module level electronics, conduits, walkways, anything you attach to a metal roof. So that's kind of the who we are. And it's important to also understand the what we do, which is, look, we're a manufacturer. We own the manufacturing. We innovate the product. We engineer it. We test it. We manufacture it in the US. And then we do what we're doing now, which is we educate on best practices and so on and so forth. And as many of you might know, and as our motto says, our motto is the right way. Here you can see a picture of not just direct attach using S-5 direct attach PV kit technology. This house is in Boulder, but you're going to see a shiny bar in the front of that, and that's snow retention. So this roof in Boulder, Colorado also has snow retention on it as well. So again, anything you guys are attaching to a metal roof, not just the solar, any of the ancillaries you have, just remember as we go through this presentation, you can use that as well. So a quick brief history of metal roofing, just so we don't intimidate anybody. Metal roofing is not a new thing. It's been around for 3,000 years, a long time. Metal roofing is used all over the world. These are some of the most famous and most iconic pictures. And these pictures were actually taken by the owner of our company, who is a metal guru. So you'll learn a little bit more about him later. So St. Marco's Cathedral, the Blue Mosque in Istanbul, and Notre Dame. So all of these have metal roofs on them. And why do they have metal roofs on them? Well, durability. They last a long time. Galvalume is typically, standing seam is typically going to last between 60 and 70 years. Now that will vary depending on the environment you're in. And conversely, some metal roofs have lasted as long as 200 years, but coated steel roofs commonly have 60 plus. So altE is located, of course, in Mass, in New England. And for those of you that live in that area, if you walk around the historic districts, you're going to see plenty of roofs that have been in service for excess of 100 years, and some all the way up to over 200. So a really long time. So again, why metal? Why is metal the perfect platform for solar? Well, it's sustainable. It's recycled. It's the most recycled construction material available at 73%, but it can be recycled 100%. It's 100% recyclable. So it makes complete economic sense. And as we're talking about sustainability, understand the metal roof platform is the perfect platform. And when you look at recycling or go to a dump or something, you're not going to see a whole lot of metal roofs in there because they can be recycled and always are. So last but not least, it costs less to install solar on metal roofs. And so for this part, I'm going to go ahead and hand it over to Mark, and he's going to talk a little bit about the life cycle costs.
Yeah, so thanks, David. So a key part of this is that if you look at solar and the roof as a single asset, which is very important to do, the economic sense are a little different than if you first installing a roof. So as you see, the cost of a roof, a metal roof is more expensive than other roofs, like a single ply membrane or an asphalt roof. It's more expensive, but it's actually less expensive to put the solar on the roof. So if you look at these combined, you know, the bottom line is now, as far as the cost of having solar and on the roof, it's a little bit less expensive to do it on a metal roof. So the cost that you paid extra for the roof, you've made up through the installation process. And we'll get into that a little bit more. But another key thing is that when we talk about the durability, the service life matchups, metal roofs are 60, 70 years or plus. So the ability to put a solar asset, which is a 30-year, 35-year plus asset on a metal roof, you can really put it anytime on a metal roof. Whereas other types of roof, like a single ply membrane, if you're not putting a roof solar on right away, you've missed that window of opportunity, and you possibly could be replacing that in midstream, midlife of your solar. So if you add that cost into it, you know, you're way ahead with putting solar on a metal roof. Just looking at it as a single asset and the service life, the lifetime cost. So just to sort of put a finer point on that, this is I don't know who recognizes this, but this is like a cash flow analysis, and that's a good way of looking at it, how to analyze a solar system. So the line on the left is your initial cost less your incentives. And then the black line is what your yearly savings are. And then this orange line is essentially, that's your net cash. So around 6 years is when this specific project, this is an actual project actually, and about 6 years it becomes cash positive, and your accumulated cash is, you know, close to $700,000. Ways to analyze cash flow is, one of them is the net present value, and I used using a discount rate of 5%, which is somewhat subjective. You know, your net present value of all that cash is $276,000 for a $145,000 investment. And your internal rate of return is about 21%, which is awesome. So now and there's the visual. That's your cash right there over your 30-year lifespan. But what happens is, if you have now these other roofs that have a shorter service life, you risk the possibility of having to replace the roof or do work on the roof. And this is to visualize that negative cash impact. So there's your hit. That blue line is that's your negative cash flow. You need to fix everything. So if you embed all that together, this is what you end up with. And that area is your lost cash. So that's really just driving home the benefit of the matching up that life cycle of a solar plus roof and looking at it as a single asset. So I'm going to go back to David.
So we're going to talk a little bit about what is RELIS PV on metal roofs. And I want to piggyback on what Mark was just saying. Look, you're not always going to have the ability to influence what type of roof type the owner or building owner puts on. But we hope you understand that when you do, you should learn more about metal. Reach out to us for that for sure. We'll put our emails back up at the end. But you do have the ability to choose the roof types you work on. And metal roofing is a very easy roof to work on. And when we're talking about direct attach and we're talking about RELIS, you're essentially using the rails that are already on the roof. So those things that are sticking up, that's called a standing seam. And S-5 works on standing seam or exposed fastened. On an exposed fastened, we just call it a rib. But those ribs or seams, that is your rail. So this is a steep slope roof that you're looking at right now. And what Mark has circled there is the direct attach technology. You'll see it up close here. So this is on a commercial low slope roof. And what I want you to notice is that there's 3 points of attachment at this. when you're attaching on direct attach or exposed fastened, you're using the rib or the seam to attach. And so in most instances, you're going to have plenty of attachment points. So the takeaway here is if you were using rails, you would have needed 3 rails because of the wind requirement for this. So really important to understand that you're talking about a lower cost and an easier install and less labor. And we're going to cover that a little bit. So this is the PV Kit 2.0. Again, extreme high winds. You could attach more frequently in some instances. It just depends on what that seam or rib spacing is. So this is 6 clamps per module. And this is an example of one of the larger jobs we've done. I don't know if it's still the largest in North America, but it was at the time almost 7.5 megawatts. It's the Apple job is what you're looking at. If you don't recognize it, it's in Cupertino, California. And I want you to understand they use direct attach on a radius roof, and they attached in portrait. We'll talk a little bit more about that. Typically landscape is easier, but they did and we're able to attach in portrait. There's over 6 miles of walkways. There's edge copings and fall protection. All of that is done with the S-5 direct attach technology. So key takeaway is when you're attaching to a metal roof, do use non-penetrating seam clamp technology on a standing seam roof. It's not going to void the warranty, and there's no holes in the roof. So railless method, referred to as direct mounting or direct attach. We trademarked this term some years ago, and we were really the first to pioneer this kind of direct attach technology. So I mentioned at the beginning, we're kind of an education company. We try to influence the industries we work in, solar included in that, as to the best practices for metal roof. And this is one of those. And we're happy to say after over 12 years of having this technology out, it's finally starting to catch on direct attach. And you're seeing micro rails and other companies come out with direct attach technology. It just makes a whole lot of sense. So the rails are already there, and you're just going to choose the correct clamp or bracket. Go ahead, Mark. And we'll go over a little bit of the PV kit real quickly here. So this is the PV kit. It has a stainless steel disc. It is UL listed, and it comes in a mid grab and an edge grab. And that disc is loose, and then the grab and the stud is pre-assembled. And that will fit on any of our clamps. Mini clamps is typically what we recommend. That just means it's a 1-set screw clamp. S-5 also makes a 2-set screw clamp. Generally, that's not needed. And when you're doing direct attach, it's not needed, but it's generally not needed with rails either. It just depends on snow loads and wind. So that's direct attach. But what about exposed fasten roofs? For those of you that don't know what an exposed fasten roof is, it simply means that the fasteners, the way the roof's attached to the structure, that the fasteners, you can see them. There's holes in the roof. So I want to just alleviate any fear or concerns around attaching into the structure, whether you go into the structure or into the rib, that when you're attaching with, an exposed fasten roof, that S-5 products, you should always get product that's tested and engineered and designed. So this bracket you're looking at is for direct attach technology. It's called a rib bracket. It comes in 4 versions, depends on the dimensions of the rib, and we can help you when we have tools online to size that. It also comes, and we'll talk a little bit more about it, with 4 self-piercing screws. So we do not use self-drillers. And that's going to give you maximum stripping torque. This actually does really, really well in terms of performance going just into the rib. And that's because of the technology we use. There's a slot on the top of it. A slot on the top of it, and that slot gives you some adjustability with the PV kit. So you do have a little bit of adjustability with it. And then you have the wire management slot, which is that large slot in between. So Protea bracket is similar. It attaches into the rib. We're going to talk about the waterproofing technology we use here in a minute, but this product can be used with rails, as you see in the bottom, or as you see in the top right with our direct attach technology. The beauty of this bracket is it's completely adjustable. With any product you're using, you just want to make sure all the testing engineering has been done on whatever product you use. This is for corrugated roofing. Corrugated roofing is a type of, can you go back a slide, Mark? Just to point out, if you see this trapezoidal shape, we refer to these as trapezoidal exposed fastener roofs. This is not a corrugated roof. Okay, Mark. Corrugated is that wavy that you get sandwiched between two pieces of cardboard, and that gives the roof a lot of integrity. So we make a core bracket for that. We make two versions. The version you see here is called the Core Bracket 100 TPV. The T stands for top fix. It goes through just the sheeting. Again, it uses our same technology on the fastener. It does have the slot and top and the wire management slot as well. So the slot and top, again, gives you that adjustability, 1 inch of adjustability. And all of our brackets have the factory applied sealant. EPDM is what we use when you attach into the rib. This just works better. There's a double-sided sticky tape on the Protea bracket, and that allows you to hold the bracket in place pretty easily when you're putting the fasteners in. So that's what EPDM looks like.
And the screws as well have washers on them, seals on them, the screws. Okay.
Yeah. And we'll take a closer look at that. I think we've got a photo coming up. I'm not sure, Mark. We're talking about direct attach, and we're talking about direct attach technology, but I did want to let you know, S-5 makes a multitude of brackets. This one is called Solar Foot. It is designed for an L foot, but when we attach into the structure of the roof, we don't use EPDM. We use something called BUTYL sealant. BUTYL sealant is when you're fixing into the drainage plane. It's what's been used in metal roofing for well over 50 years. This is an actual study that was done with our company, the owner of our company, and the metal roofing industry. And it analyzed how long does a metal roof last. And we took roofs from all over the country. They looked at the sealant as part of that study and found that this type of sealant is easily going to last well over 60 years. I mean, this still had another, I can't remember exactly, but it had a lot more time on it before it was going to dry out. You can see how pliable it is. So understand BUTYL sealant is tried and true for metal roofing. Our fastener technology, as Mark was saying, does have a gasket. This is go ahead. This is what they call a self-piercing screw.
No, this is a
self-driller. I'm sorry, a self-driller. Mark, can you go to the swerve? There you go. So when you have a self-driller, a driller does what? It drills, and it's going to remove parent material. That parent material is the metal shavings, and it's called swarf. And that swarf will fall on the roof, and it will cause rust on the roof, and you'll get rust stains as you see here. So that's what those swarf particles do. So that's no good. We use a self-piercing screw. A piercing screw does as indicated, which means it pierces. This is really important. It's going to create a pocket. You can see that pocket in this animation. And that pocket allows for better pull-out strength, also helps with waterproofing, and you have the black EPDM gasket around the fastener itself, as well as the EPDM EPDM on the bracket itself. So you actually have a triple water seal. And how do we know this? All of our products, we are a testing company, as I mentioned at the beginning of the presentation. All of our brackets, the BUTYL sealant, the EPDM, whether they're attaching to the structure of the rib, are all tested to ASTM 2140. I don't know about you guys, but I'm not big on the names. What does this mean? It means it doesn't leak. It's a bathtub submersion test, and it either leaks or it doesn't. It's pass, fail. There's no grade in between. Of course, we passed. There's no leaks. So that is why it's important to whatever product you choose, whatever brand you choose, that they've done the appropriate testing. We also have load testing, which we provide to you as well for our clamps and our brackets.
David, before we go on, there is one question that's about the solar foot specifically. Do you want to answer that?
Sure. The question
Just
is, the solar foot, what are you expecting it to be screwed into? It is wider than a usual 2x4 support, but strapping doesn't seem reasonable. Is it expecting a full underlay on the roof? Great question. On our load test tables under our website, under resources, you will see something called load test tables. We test into OSB, we test into just the purlin, and we test into just the wooden truss. Depends on the bracket. Different brackets have different testing, but it's generally what we test into. As far as number of brackets you get in, or number of fasteners, depending on the bracket, sometimes you can get all of the fasteners in. If you're going into decking, obviously you can and you should, but if you're going into purlin, you might only be able to get 2 in. And so you always want to put the upslope ones in, and you will see that reflected on our load test data. Great question.
Okay.
And again, this is meant to be a direct attach presentation. We have others, and for time's sake, we're just going to keep plowing forward. So why S-5 and direct attach, and why is it so appealing? You're going to have reduced material cost because there's just less of it. You're going to have reduced freight cost. Think about rails and think about our product, how small it is. The labor cost, there's always a learning curve, but with direct attach, particularly on commercial buildings and the larger buildings, you're going to save so much on labor and time. And once you get it dialed in, you'll never want to use rails again. There's also all of the reduced handling costs, but something that doesn't get looked at a lot is the reduced dead load. Keep in mind, when you're attaching to a metal roof, you want to spread the load. When you're using direct attach technology, it's forcing you to spread the load on the roof across those seams or ribs evenly. And that's that increased distribution load. The reduced dead load, just a lot less weight than railing. And as we said, faster.
Okay. So I'm going to jump in here.
Yep, hand it back to
All
Mark.
right. So this is just a video of showing how the direct attach is assembled, how it's installed. So this is done in our own office. So what's key is you only have to measure that first row. The time savings comes because you don't have to measure and locate rails as you would with rails, snap lines. So you hit that first line and then everything else after that is on the fly. No more measuring. So as you put that module in, you'll see that the next one goes in on the fly. You'll see that in a second right there. So that's going in, no measuring, that just went in and then it's done. And then you just tighten it to the roof and then tighten it down. So he'll keep going. I'll just show a little bit more of this. Then they kind of line things up and then the same thing. You'll see in 1 second. So that is showing this as it's lining up on the fly. So there's no need to measure as you would do rails, basically. And then there's the same Torx wrench is used for the top and the side, and basically that's it. That's the crux of it. Okay. David, back to you.
I think we had a question come up. Are the screws provided galvanized or stainless? Depends on most of our screws are stainless, to answer your question. The screws that we sell and the screws we're talking about for these rib only attachments that go into the sheeting only, those are stainless. So quick project comparison to just take a look at the cost, very high level. Very high level. So
this was an actual project that we did the best we could do to really compare prices, but every project is different, as you know.
Mark, what was the size on this one?
150 modules.
Yeah, this is 150 module. It was done comparison with rails and direct attach. Again, at the time we did this, it was real pricing. You're going to find this to be fairly accurate, but feel free to run your own, or we could help you do that. So PV kit, you had a 42% material savings, 30% time savings. Now that's on installation. Shipping cost is huge for 61%. And then the install cost per watt overall, 38, almost 40% savings. But look at 22 cents per watt versus 13 cents per watt with direct attach.
And that's less now. This is now, it's less than that because modules have gotten bigger. Go ahead.
Rail, and just the cost of rails have gone up, as everybody knows, over the last year. We could spend days talking about that. The cost of shipping has gone up. Now, this is a different project. This is a 250 kW, and Mark and I always like to say a picture's worth 1,000 words. So this is a 250 kW job. Think about that in dollars today with this weight, 4,700 pounds. Think about what that costs, not only to ship it, but now you've got to have special equipment, get it up on the roof and take it off the truck and all that stuff. Same job, 750 pounds, S-5. Put it for a residential job, it goes in a 5-gallon white bucket, carry it up on the roof. So I'm going to turn it back to Mark. He's going to talk about some of the challenges that face EPCs and installers as it relates to direct attach.
Yeah, so there are a few nuances what we'll get into, but the point of this slide is that things are changing, evolving technologies, and there is definitely some hesitancy because people have teams, everybody's well trained, get up on the roof and they just go to town. And now to take the time to reset that learning curve, we're aware of that, and so what the point of our ongoing training and the support that we provide all the time is really set so that we minimize this and get people, once you're in the groove with this, I think you'll find that with metal roofs, especially, a direct attach system works well. So one big part of it is about just the fit. And if you're used to a rail, you lay the rail along and you just put the modules where you need to put them. With metal roofs, whether it's standing seam or ribs from an exposed fasten, it is a little bit different. So as we know, modules have clamping zones. These are the green and yellow zones. You shouldn't put primary clamps in those red areas. Every module is different, but there's a lot of similarities. We all know this. And now if you look at metal roofs, it's a mismatch. So the metal roof standing seams can be 12 inches to 24 inches, and some are even more. Corrugated, and these are exposed fasten. The trapezoidal ones are tighter, 6 to 12 inches. Corrugated are even tighter, 2 3/4 inches is standard US standard.
And Mark, just to comment on that, so everybody knows, like Mark said, some are wider. What we're giving you are on standing seam, on exposed fasten. This is what it'll be, or corrugated's closer. But on standing seam, there are times where you might not be able to use direct attach technology, but it's not very often. So just keep that in mind.
Yep. So this is so what it is, though, it's really just math. So you have to take the time, in prep time. This is done at the desk, where you're just matching up the loading zones with the seam. So you just can't start at a starting point and go to town. You have to make sure that you're hitting these. And this is an example of a real project. And these are very wide seams. These are 42 inches, and these are 72 cell modules. So you can see that every other module, there's a 10-inch gap. So we understand that there's a lot of pressure to increase the density to use up every square inch, but there are some benefits to this. With this, you do get access. You can, if there maybe you do 8 inches and every other one you do 13 or 14 inches, then you can walk on that. You can perform O&M. Actually, the installation is easier. So there's benefits to that, obviously. But of course, we understand it's a balancing act. In most cases, things fit. And the tighter the spacing, when you get to corrugated or trapezoid, you usually don't you can do whatever you want. You just got to be aware of it. These are some examples. This one, there was about a 7% loss of space due to these correction gaps, we call them, for O&M. And well, they're based on the matchup of the spacing and the module loading zone, basically. Here's one. It's hardly even noticeable. You can see that in the background, that one gap. Really minimal. This one, you can barely see it from a distance, but they are there. That every 6 or 7, I think, or 8, there is a correction gap. And there's, as I said, there's benefits, pros and cons to it, and everybody's going to make that decision. So another area where you really need to understand and get over the learning curve is wire management. People look at rails and say, obviously we're just going to zip tie all the wire, all the jumpers, whatever we need to on these rails and call it a day. And if the only reason you're using rails is for wire management, then it's pretty expensive wire management. But there are definitely steps to take that make this work. One of the big ones, and I'm going to talk about 2 basic ones. One is module prep. So what you do is you just figure out, how can I make sure that when these things get up on the roof or being put in place, as on the right, you don't have to reach under or lift up and play with wires. They're already clipped up. They're already set to go. The one picture on the left, there's a lot of clips there, but they're very inexpensive. And as you're sliding this module in place, it just, your conductors are there. This is within a string. And, that just minimizes that time and any of that angst that you see, that you would imagine by not having it zip tied to the rails ahead of time. Here's just a plethora of clips that are out there for whatever need you have, however it fits, you can find the right clamp, the right clip. And we sell a lot of those now. The second part is what I call strategic string design, is really taking the time to look at where your string ends are. This is for a string inverter or central inverter, and take that time to really understand, how can I minimize my work? It's good practice all the time, but it's just more acutely aware of it with railless systems. The product on the left is a sequential, what you'd get out of just using a design tool or just sort of the easy way out is doing the sequential. The one on the right, there's some thought into putting, how can I get my string ends closer to that home run to minimize my jumper wires, to make that easier. And it's amazing how much that will help. It's hard, you may not think that they can make a big impact, but it really can. And it's not a perfect, it's not cut and dry. There's definitely different ways to skin the cat with this. No right answer. So here's what's showing if you're trying to put those jumpers down to the home run. So on the right, it does look easier. It's a little bit more organized, and you just have less travel, less clipping up on the modules. I mean, the thing about having a direct attach is you have to, as you're installing your modules, you got to pull up and clip up the wires that are on the roof at that time. So there are ways around it. I'm not going to go through all this discussion, but so part of the strategic string design, you can really look at, okay, this is an example of sort of what I would call the perfect scenario. This is 20 columns. They're split after 8. And what that does, they use strings of 16, and they were able to put all the string ends on the periphery of the subarrays by making one gap and using inverters that are 16 modules long inverters. So you could look at your subarrays and do some pretty amazing things by just putting some thought to that, and that's all done at your desk, whoever's designing it ahead of time. This is just sort of a really great example of it. Obviously, the world is not perfect, but this is some of the things that you can gain from that. One method
Mark, you've got a really good time appropriate question if you want to take a look at it from Brian.
Looking for wire management tips on the system when paired with Yiga rapid shutdown devices. So I'll get that into that in a second, but that is what I'm calling module level power electronics. I'll get into that in a few minutes. I'll definitely address that. And then the other one, please mention the importance of knowing where the standing seam and roof protectant clips are. Okay, we'll get into that. So, so this is what I call the trunk method. It's basically what you're doing is you're putting wire management trays underneath. And what that does is that really reduces the amount of clipping you need to do. So as shown in that illustration, those are wire management trays. And so at the point where you have your string ends, you just have to funnel them to the wire management tray. Then they go right to the home run. The picture on the right, actually, reason I have that there is that's actually a rail-based system. That's a 4 megawatt on a single roof in Massachusetts. Huge project. So they did the same thing, just to not have to wire tie or everything. What they did was basically run that wire tray underneath, and whenever they have those string ends, you can see the string ends there. They just zip time only to the point of when they hit that wire tray, and then after that, they're just loose and bundled in that wire tray to the home run. So it's the same method that you would use for a direct attach system to minimize the amount of clipping up, and it works really well. An offshoot of this is to actually have these wire trays on the outside edge. So these are probably covered, but all that's accessible, and all they had to do was really just make one gap there to have that work with 3 wire trays. So with some thought into this string design and how you do this, you can really adapt and utilize a direct attach system. So on the steep slope side, you're usually talking about smaller systems. So wire management is not the big, it was really, nobody pays a lot of attention to it, although the same practices can be used. But the issue with steep slope, it becomes people use rails as footholds. Fine. This picture is just sort of showing how difficult it is. No matter what you're doing, rails or no rails, it's not an easy manner. This is kind of a comic, a few funny pictures, but it highlights just the difficulty overall. This slide shows, people use rails as step on, but you don't have to. And if you're having rails there only to use a step, footholds, it's expensive footholds. So what we advocate for is, especially if you're moving material up, is building column by column. So it's key that you have, as we know, you're saving money because you're doing you're installing the clamps on the fly, the module is the jig, you're pre-building this stuff, and then you're building column by column. And let me show you. And the reason for that is just about the scaffolding, making sure you have place to step on and fall protection. So as shown in that video, you snap a line and do your first row of clamps. You need to do that. So there they are. And then what you do is your scaffolding's up, and then the module goes in, the clamps go on the fly. The yellow arrow that's your material flow. So you can't shut yourself off. You have to, this is the way to go. So now you move your scaffolding over and you build there. And just keep going and going and going, column after column. And this works. So alternately, if your modules can come from the sides or from the other side over the top, you can actually do a row at a time, the bottom row. And then what our best practice is from Sean Haddock, who is our training guru, is to create an L and spend the time to line that up and make those look pretty and lined up. And then the rest just fill in. And your material's coming over the top from the side, so you're not stepping on each other. That works really well. So there's no right answer. You got to really look at, how can I get my modules up on the roof, what direction, and how best to do it. You want to prevent this next slide. So there you go. The next slide is, you do not want to do this. If your material is only coming up from the bottom up to the top in the front, and you put a row across, you've locked yourself off. Now you're stepping on modules, and it makes life a lot worse. So that's your worst case. What you want to do is figure out where my modules are coming from, and then kind of build accordingly so you don't trip over yourself. Along the way as well, module prep is key. You really want to create a repeatable process that's repeatable, reproducible. So the guy up on the roof, all they have to do is clip them together. And the more time you spend on that, on the ground or in the staging area, pays off on the roof. Can't stress that enough. And I've seen enough where they may do sort of a half job of clipping stuff up, and then when they're on the roof, they're reaching under, moving things around on the roof, and that's not what you want to do. And it makes it worse with direct attach, because they tend to be lower profile. It's harder to reach under there. But you don't need to. If you do this, spend the time to do this as much as possible. Here's some pictures showing this column up, column at a time. This is our own manufacturing plant in Texas. So you can see he has that ladder tied up. He has fall protection, and he's building up the column. So now let's get into module level power electronics. So now addressing your question, Brian, is rapid shutdown devices. Is that what you're talking about? Yeah, so a rapid shutdown device is similar to this. So for rapid shutdown and for optimizers, for me, hands down, you should put it on the module if at all possible. No brainer, because you spend that time off the roof, clipping this, prepping that, and you can prep the optimizer into it, so that when what you end up with is you end up with 2 conductor wires, just like you would if you didn't have that. So the rapid shutdown falls in this category. Optimizers fall in this category. So it's the same thing. When these get up on the roof, that guy is just clipping them, lowering them in place and clipping them. But so you have more time prepping. So you still have one guy down there prepping this, and this really, you're not adding any overall time to your cycle to your, time on the roof by doing this. So optimizers, no brainer, put them on the module if you can. Here's clips again, showing just, all the clips can be used, and wire ties to just keep that up out of the way and prep that module. That's really key. Microinverters are a little different. So microinverters have that trunk cable, AC. So you have to do something on the roof. There's no way to avoid it. So one way, this case on the right, is they put the microinverter on the roof ahead of time, laid the trunk cable, connected them together, and then as they're lowering the modules in, they then connected the modules to the microinverter and clipped up the trunk. What I would prefer to do, as much as possible, is to put the microinverter on the module as well, connect it there, lay your trunk cable ahead of time. So when you're putting the module in, you're plugging in the trunk cable and you're just clipping that up. But that's less cut and dry than the optimizers and rapid shutdown devices. So here's putting these on the roof. We actually have a device which is on the right, our gripper fix for our utility scales, our utility line, which can act well as mounting this stuff on the roof. But it's really the same clamp technology we sell that mounts these things, as you can see. So to balance out the system, and this is sort of another plug for metal roofs are great, you should go out and find metal roofs to close deals on, is that all the balance of system, using clamps, the same technologies, is very easy to do with home runs, junction boxes, combiner boxes, walkways. It's just really easy to put that stuff up on metal roofs. And now I'll have Davis take us home.
Yeah, so a little bit on what makes us different. I kind of set the stage at the very beginning that we're a metal roof company. We were founded almost 30 years ago. I always like to say it's important to understand when you're doing business with a company, what's their background? Our background is metal roof. It was started by a gentleman named Rob Haddock, who came out of the steel erection business. That's what he's done his whole life. He is a metal roof, or what we call a forensic metal roof consultant, and he's one of the top metal roof consultants in the entire country and one of the top 10 in the world. So when something goes wrong on a metal roof, he gets called in. So feel free to call us with questions as it pertains to attaching to a metal roof. So this is our manufacturing plant. It's in Texas. We've done 4+ gigawatts. That's a lot of solar. Like I said, well over 12 years now of our PV kit alone. And we've been used on solar in some fashion for probably close to all of that 30 years. 2 million metal roofs worldwide. We do have a limited lifetime warranty, 100% made in the USA. And perhaps one of the most important things is the certifications and testing. We do everything from load and wind testing to fire testing and everything in between. We work with all sorts of code bodies. So our plant is audited on a regular basis. We don't outsource, we own the plant. And we have certified manufacturing, but our materials are equally certified. And with that, this is some pictures. Our plant is solely designed to produce nothing but our widgets.
So I want to address, Gail, you had
hold on, Mark. On that question, I'm gonna go ahead and share my screen if I may.
Yep.
So if you want to,
right.
All right. So I'll show you a picture because I think Mark was going to
Are you
the
showing? Are you
frequency of the frequency of attachment picture. So let me just
So the question is about roof clips touching.
Yep. Yep. Bear with me just a second here. And I will pull that up.
So you don't see my screen, right?
No, they should see mine. Can you
Yep,
guys
I've got your screen, David.
can you see it?
Yep.
All righty. Awesome. So the question was, where should you attach on a metal roof, and are there any things you should avoid? Real quickly, there's two types of clips. These are the clips that attach the roof to the structure. We're talking standing seam only. If it's this type of clip, a dual component, and you put a clamp on top of it, nothing bad will happen. That's fine. That's acceptable. Meaning that roof can expand and contract. These clips are going to be found on large jobs, commercial, industrial jobs. They're called dual component clips, and it allows the roof to expand and contract. Conversely, there are what they call single component clips, and these are the ones you want to avoid. If you don't know what type of roof clip is on there, go near the clip, but not on the clip. These are going to be used, not always, but mainly on small commercial and residential types of roofs. And then the last question is probably going to be, well, David, Mark, how do we know where the heck the roof clip is? Look, roof clip is what is designed, pardon me, roof clips are what holds the roof to the structure. So the design is based on loading, wind loading. So they're going to be attached fairly evenly throughout that roof. In the wind zones, they'll be spaced evenly, and in the middle of the roof, they may be spaced further apart, but they're still going to be equal distance apart in that zone. So what you're looking at here is a little bulge. These clips are going to be 16 or 18 gauge, so they're going to bulge and they're going to be equally distance apart. So once you find one, you can just follow that down and attach near it, but not on it. Does that answer the
Seems to
question?
be. I mean, she could ask another
I'm
question
gonna
about that.
stop sharing here.
Yeah. So then there's a final question, one question about hurricane resistance in South Florida, standing seam applications. We have actually a good history of being on roofs in Miami-Dade, in the Bahamas, other islands, and have actually had buildings go through hurricanes. And one actually aspect of standing seam metal roofs and putting solar on them using a clamping technology, whether rails or not, is that the clamps actually strengthen the roof strength of the roof on the building. Because what they do is they pinch that seam. It's like if you're holding a Ziploc bag and it bursts, it rips apart at the seam. Now, if you put your finger on it and hold it together, it can take a lot more pressure. So that's reflected in these buildings actually do better if they have solar on them using clamps, roof clamps, than if they didn't. And we have a lot of test data. We're Miami-Dade, we've been on single-use NOAs in Miami-Dade. So we're in a lot of places in these areas, and we have the test data that you have to engineer the system to work. And we have data that helps people engineer the system to withstand whatever wind force you need to.
Mark,
So,
I put up the picture of the wind testing.
yeah. So we've undergone, through FM, companies have gone through testing, and we have as well, this uplift wind testing. And what that is that just showing how much the roof gets stronger by using clamps, actually, which is an inadvertent side effect of putting solar on a roof.
Yeah, so what you're looking at here is this is an actual standing seam roof where the panels have been deflected, right? And you can see that they're still attached to the structure. So like Mark is saying, using an S-5 clamp for whatever you're attaching actually improves the performance. Now it's going to vary by roof.
I think the key thing is that we have the data. We help people work with Miami-Dade, for instance. We do, and we will help get through hurdles and provide the data that's needed to show that the engineered system, knowing all the forces, whether you use ASC 716, which is now used in Miami, whatever that's designed, you can design a system with our product, and we have the data to back that up, and we know Miami-Dade.
So S-5 does a series of courses. You can access a lot of that on our website. You can also go through altE and say, hey, talk to Sean over at altE and say, hey, we'd like to see more, S-5 training, and we can certainly do different trainings through altE. We're happy to do that at any time. And that might be the best way to do it. That way we customize it for you guys and gals. So this is the Miami-Dade approval. And then we're also LA County recognized, which is LA's way of saying we're LA approved, but they don't use the word approved. So just keep in mind, we are a testing company. I'm just throwing up some quick photos. We do all sorts of testing that other companies probably don't even think to do. So,
yep. And that, you know, that's one of the reasons that attracted me to this company was two things. One is the amount of engineering and testing that goes into our products, and the customer service that we provide, the technical service. I'm obsessed with that, passionate about that, and so is S-5 as a company.
any other questions? Last minutes, if you want to throw them up there. We missing any, Mark?
We got everything. If anybody wants more explanation, talk to us later or just type something in now.
Did you address also expected lifespan of brackets in Oceanside application? Did you address that? So I should have kept that presentation up for another second. We've done salt fog testing.
Right.
Keep in mind, depending on the type of metal roof that they use, the aluminum bracket or aluminum clamp is going to outlast the roof, not only from a strength perspective, but from a life expectancy. And that's why we use aluminum. Now, if you don't want to get aluminum oxide build up on it, that chalky white look, you can powder coat these or anodize them for coastal, but nothing bad's going to happen to the clamp itself. It's absolutely fine. So I see.
So there is a question as well. Sorry.
Go. I was just saying,
torque
50
specs,
feet from the water, you might want to, you might consider anodizing. I don't know if it's residential or commercial, but totally up to you. Go ahead, Mark.
So torque specs. So another question. So yeah, so our installation manual have all the torque specs on it. You know, we arrived at those from testing and from working with roof manufacturers for best, you know, the best way to apply it. So those are documented in our installation manuals.
I was gonna see if I could quickly put my fingers on the salt fog testing. So this is
I don't have any.
Can you guys see that okay, Mark?
No, I don't see it.
So not sharing my screen. All right, well, any rate, if we don't have any questions, I can't see the questions, Mark, so.
Somebody just said, are there plans to get UL listed for bonding for the metal roof? You know, that's so to the metal roof, that's sort of out of scope of UL 2703. We are actually working on something to address that. And another part of it is we have a system, our clamps go into lightning arrest systems and just all around bonding and grounding to the roof itself. But right now it's really out of the scope of 2703 and listings. I mean, you may have individual AHJs that push back on that, but you know, the roof is grounded. Our system is grounded. I mean, our product, the PV kit, is UL listed for bonding and grounding frame, so you don't have to put lugs everywhere. So we have that certification. But you know, the way 2703 now works is it's the roof. Anything below the product is out of the scope of the system.
And expand on that a little bit. So what Mark is saying is, if you take the PV array off, right? Just forget the PV array. You get a metal roof. There's no code that requires every metal roof panel to actually be bonded, because like Mark said, the structure is run to ground. And what throws the AHJs off is that phrase in the NEC code, likely to be energized, right? So as Mark said, as of right now, the PV kit is UL listed, but not for roof panels, just PV kit and the clamp.
And the module frames, basically.
Right. You don't have to,
I mean,
you don't have to use copper and lugs. The
Wires
disc.
cannot lay on the roof anywhere. So you have to pick them up and clip them up. That's what, that's what's important about that.
I threw up a picture. You should be able to see my screen now of the salt spray test. But for whoever asked that question, keep in mind, we've been around for 30 years. So we know how our product is actually going to perform on the roof. So we've outlived many roofs out there. So.
Right. Well, we are up against the hour here, and a lot of our attendees will be heading into another session pretty promptly. So, yeah, I think we can wrap here.
Thanks, everybody.
And again, yeah, if you have any further questions for David or Mark later, please join them in the open networking session at 3 p.m. Eastern today. Thank you, David, and thank you, Mark. Great presentation.
Thanks.
Thanks, guys.